going to be adding a push-button vibrato effect to your Werkstatt. For this project, you'll need an LED, a photocell, a momentary push-button, 2 1K resistors, a 10K potentiometer, a breadboard, jumper cables, and an Arduino. You'll also need a way to upload code to your Arduino. First, we'll need to connect our push-button to our Arduino. Momentary push-buttons like this complete the circuit when pressed down between 2 diagonal legs. Go ahead and run a jumper cable from the 5-volt out on your Arduino into the power section on the breadboard. This would be a good time to also run a ground cable from the ground of your Arduino into the ground section of your breadboard. Our momentary push button is going to simply send an on-off signal to our Arduino, so we'll need to supply it with 5 volts. Run a jumper from the power section on your breadboard into a leg on your push button. Now run a jumper from the diagonal leg on the push button into digital input 2 on the Arduino. This is the digital input that will be able to read whether or not our button is being pressed. To ensure that our button doesn't send false positives to our Arduino, we'll need to attach our 1K resistor from our signal line to ground. Next, we'll need to plug in our LED to our Arduino. An LED is a polarized component, so there is a positive and a negative. The positive lead of the LED is the longer one. So first, we'll need to plug in the shorter lead of the LED to ground. From the longer lead of the LED, run a 1K resistor. Next, we'll need to run a signal line into our LED from our Arduino. Run a jumper cable from the 1K resistor connected to the positive end of our LED into digital pin 6. Now, let's hook up our 10K potentiometer to control the vibrato rate. Run a jumper to ground on the A or B terminal on the potentiometer. These are either of the outside pins. The middle pin, or the wiper terminal of our potentiometer, is the signal pin. Run a signal jumper from that to analog input 0. Finally, run 5 volts into the unconnected terminal of the potentiometer. Our last step is to plug one leg of our photocell into the positive 5 volts on our breadboard, and the other leg into the VCO EXP in. To isolate the photocell and to ensure that it doesn't act erratically when we're not using it, I like to use a little piece of heat shrink tubing that's sealed on one end to enclose the LED and the photocell. Last thing we need to do is just run ground from our Werkstatt to share with the Arduino. To do that, I'm just going to loosen one of these external screws and attach a jumper cable. Once we're sure that all of our breadboard components are connected correctly, it's time to upload our code. You should hear a vibrato effect when you press the push button. Now the potentiometer connected to our Arduino actually controls the rate of vibrato. If you take the heat shrink tubing off and look at the LED while you hold down the push button, you'll see that the rate of the flashing of the LED changes as you turn the potentiometer. Now you'll also notice that when you take your hand off the push button, the LED stays on. That's to ensure that our pitch is kept at a constant rate, and when we press the push button, it modulates around that fundamental frequency. Variables in the code can be manipulated to control the lowest brightness, medium brightness, and highest brightness of the LED. By editing these 3 variables, we can reset the floor, ceiling, and range of our vibrato effect. By separating our vibrato from the LFO, we're able to use that low frequency oscillator to modulate other parameters. By using both of these simultaneously, we're able to achieve more dynamic sounds with our Werkstatt. All fritzing models, parts lists, and schematics are available online at Werkstattworkshop.com.